Okay, so in this tutorial, we're going to review how to make a best fit line and how to find the slope of that best fit line. Now, using your ruler, take your ruler and put it on its end so that the long flat end of the ruler is standing up and you can see dots on either side of your ruler. And when you have that done, you're going to lay the ruler flat down on your desk and you're going to draw a straight line that goes right through your data points. It will kind of look like this. Now you'll notice something about my best fit line. It doesn't necessarily have to go through the origin, right? Mine's a little bit above the origin. It does not connect the first dot to the last dot. And it most certainly does not connect the dots. Please don't do that. What it does do, on the other hand, is it goes right through the middle of your data points, and it represents a graphical average of your data points. So you should see some data points below the line, some data points above the line, and some data points on the line. That would be referencing a good best fit line drawing. Now let's talk about how you find the slope. To find the slope, we're looking for what's called a convenient point. Two convenient points, actually. A convenient point is when you have the box of your graph paper and you look at the upper right-hand corner of the box and you see that the best fit line crosses right through that right corner of the box. So here's what you do. You start at the bottom end and you just work your way up. That's pretty close, but let me see if I can find a better one. There we go, right there. Does everybody see how that's going right through the corner? The best fit line goes right through the corner, the upper right-hand corner of that box. Well, I circle where it goes through the upper right-hand corner of the box, and then I look for another location. I've got to find two. There we go, there's the other one. Okay. Now at this point, what I'm going to do is I'm going to make a slope triangle that goes from one circle to the other. I'm going to go up, and then I'm going to go over. Now, in 7th grade, you learned how to do slope by simply going up 1, 2, 3, 4, 5, 6, 7. In other words, you were counting boxes up and over. And in 7th grade, this slope would be 7 over 9. But what we're going to do this time is we're going to do it a little differently. Instead of counting boxes, we're going to use the scale on the side. Take a look at the top part of the triangle and go over to the number on the scale. And you might even go so far as to write it down. I do. 30. It's pointing at 30. Then I go over to the other side, the bottom part of the triangle, and I can see in my example, right, it's pointing at 16. Well, I've got to subtract those two, but if I do, I get 14 centimeters. Okay, and that would be my rise. My rise is 14 centimeters. My run, I do it the same way. I take the right part of my triangle located here, go all the way down, and I read off the number. Now that value is about 9.5. Then I read off this value, which is about 5. Notice I'm writing the values from the scale right on the slope triangle. Just makes everything so much easier to calculate. This will help me find my run. In this case, my run is 4.5. I get 4.5 by subtracting 9.5 and 5. The last thing we need to do to construct this is simply calculate the slope. Remember, slope is rise over run. So in this case, slope is going to be, in my example, 14 over 4.5, which is approximately 3.1. Now, that's as far as I want you to go in this lab, is be able to construct a graph, make a best fit line, and find the correct slope of the best fit line that matches your data in your best fit line. In future labs, we'll talk about how to find the physical meaning of slope from your lab.